Today we're going to talk about how you find a derivative of a function. I'll give you a function f of x, and we're going to find the derivative at some particular points. So if you recall from the last video, the derivative is the same thing as the rate of change of a function at a particular point, because the rate of change usually changes if you have a nonlinear function. The derivative is also called the slope, because rate of change is slope of the tangent line to the curve f of x at some particular point. So let's start out with f of x is equal to negative 4x plus 5. If I want to find the derivative of this function, then I'm going to use the definition of the derivative. And then if I want to find the derivative of this function at any particular x value, I just substitute x equals whatever the value is. Now, up here at the top, the derivative of a function, the function, if it is called f of x, then the derivative has a little like apostrophe here. This is called f prime of x. Because this thing is called a prime sometimes. F prime of x. So you'll see this written a bunch of different ways. You might see me ask, what is the derivative of a function? You might see me ask, what is f prime of x? And f prime of x, the derivative of the function, let's see, there's f of x. I'm going to say find the derivative at the point on the graph, let's say 1, 1, because 1 would be on this graph. If you let x equal 1, the y value also equals 1. So f prime of x, the derivative is f of x plus h. There's f of x plus h minus f of x all over h. And we're going to let the limit, or we're going to substitute h equals 0. So actually we should write out this is the limit as h approaches 0 of this particular function. So if you distribute the negative 4, you get negative 4x minus 4h plus 5 minus a negative plus 4x minus 5 all over h. The 4x's cancel, the 5's cancel, and this h cancels with that h. So this answer would be 4. And you don't even have to substitute h equals 0, because no matter what, the derivative, negative 4. The derivative of this function is always going to be equal to negative 4. Well, this makes sense because this is a linear function. This is not linear, L-I-N-E-A-R. Okay, it's linear. It's just a straight line. Linear functions, because it's a straight line, negative 4x plus 5 would be looking something like this. The slope is always the same. And in this particular function, if you remember y equals mx plus b, m is the slope. The slope of this function is negative 4. And remember, the slope is the same thing as the derivative. So this function is linear. The slope does not change as you move along this graph from anywhere to anywhere else. The slope does not change. It's always negative 4. So that means the derivative f prime of x is equal to negative 4. The derivative of this function is negative 4 no matter what. So if I want to find the derivative at 1, 1, the derivative is negative 4. It doesn't matter what that point was in the beginning. So that's the simplest case. That's a linear case. Let's get to a quadratic case. Let's say f of x is equal to x squared minus 3. And I want to find the derivative at point, let's say I put in -4, -4 comma 13. When x equals -4, the y value is equal to 13. So let's find the derivative of this function at this point, -13. Well, remember quadratic parabolas, the slope is going to change. It's not going to be like a linear function. So the slope is going to change depending on where you are on this graph. So we're going to find the slope here at -4, 13. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, which is the limit as h approaches 0 of x squared plus 2xh plus h squared minus 3 minus x squared plus 3 all over h. The x squareds are going to cancel. The 3's are going to cancel. One of these h's will cancel with that, and that is equal to 2x plus h. But if we want to take the limit as h approaches 0, the limit as h approaches 0 of this function is just equal to 2x. I'm just substituting h equals 0. So 2x is the derivative of this function that I gave you, x squared minus 3. F prime of x equals 2x. So now what we're finding is at the point -4, 13. So we're finding f prime of -4. That means when x is equal to -4, the derivative of this function is 2 times -4, which is equal to -8. Now if we do a quick sketch of this graph, y equals x squared minus 3, you know it's just a parabola that's been shifted down 3 units. It's got a y-intercept of -3. It has a point here that's called -4, 13, way up here. And if you wanted to find the derivative, what you're actually finding is the slope of the tangent at that point. And you could see that the slope of this tangent would be negative because it's going down, and it's quite steep. So the slope of the tangent at point -4, 13 is equal to -8. That's what the derivative means, the slope of the tangent line at that particular point. Now if we want to crawl along this function here, and maybe let's find the derivative at this point when x equals 2, y would equal 1. So let's find the slope at 2, 1. Well, this derivative should be positive because this slope is positive. Well, all we have to do is find f prime of 2 and substitute 2 in for x. So 2 times 2 is 4. So the slope of this tangent would be 4. If we were to draw a tangent at 2, 1. So no matter where you are on this parabola, all you had to do is substitute x equals whatever the x value is. Like if we pick this point down here, this point is 0, -3. And at the bottom of a parabola, the tangent is horizontal. So at point 0, 3, if you want to do f prime of 0 when x equals 0, 2 times 0 is 0. So that is a horizontal tangent to this curve with the slope equal to 0. Let's do another one. Let's say f of x is equal to x cubed plus x. And let's try to find the slope, or let's find f prime of x. Let's find the derivative of this function at 1, 2. When x equals 1, y would equal 2. So let's find f prime of x at 1, 2. Well, we need to find f prime of x first. That is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, which is equal to the limit as h approaches 0. If you cube that, you get x cubed plus 3x squared h plus 3xh squared plus h cubed plus x plus h minus x cubed minus x all over h. The x cubes are going to cancel, the x's are going to cancel, and one of the h's cancels out in each term. So this h cancels out with one of these two, or one of those two. This becomes h squared, and this becomes a 1. So that would be equal to the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 1. And now when you substitute a 0 in for h, we get 3x squared plus 1. So there's the derivative. F prime of x is equal to 3x squared plus 1. At the point 1, 2, we're going to let x equal 1. So we're just finding f prime of 1, and that's 3 times 1, which is 3, plus 1 is 4. So the slope at this particular curve, I'm not exactly sure what this looks like. This isn't one of our parent functions, but I could probably just look at it on the graphing calculator. So at point 1, 2, f prime of x is 4. That means the slope of the tangent at that point is positive 4. Let's see how we're doing. Let's do another one. Let's do a radical. Let's say f of x is equal to, let's just do the square root of x. Let's just make it real simple. And I want to find f prime of x at the point, let's say when x equals 9, y is equal to 3. So 9, 3 would be one of the points on this graph. You know, the square root function looks like this, so it should be a positive slope. F prime of x is equal to the limit as h approaches 0. If you want to try this on your own, you can shut off the video at any time and then pick it up and watch me do it, of the square root of x plus h minus the square root of x all over h. Going to rationalize that numerator. Square root of x plus h plus the square root of x, all over the square root of x plus h plus the square root of x. So that's equal to the limit as h approaches 0 of x plus h minus x all over h times the square root of x plus h plus the square root of x. The x's cancel. This h cancels out with this and becomes a 1. So this is the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Well, now if we substitute h equals 0, we get the square root of x plus the square root of x, which is 1 over 2 times the square root of x. So we can summarize that and say f prime of x is equal to 1 over 2 square root of x. And now at the point 9, 3, f prime of x equals 9. It does not matter what y equals on these derivatives. So f prime of 9 is 1 over 2 times the square root of 9. 1 over 2 times 3 is 1 over 6. So there's the derivative at that particular point. The last example I want to do is a rational function. So let's say f of x is equal to 1 over 2x plus 1. And I want to find f prime of x, and I want to find it at the point when x equals 3, y would equal 1/7, I believe. So let's take a look at that. Find f prime of x. F prime of x is equal to 1 over 2 times x plus h plus 1 minus 1 over 2x plus 1 all over h. Now we have to get the LCD, which is this denominator times this denominator. Well, if I multiply the LCD by each one of these terms, what ends up happening is this denominator will cancel, and this 2x plus 1 would come over to this numerator. This denominator cancels, and this 2 times x plus h plus 1 comes over to this numerator. So that's just clearing the denominators. And then, like we said in class, this denominator you have to multiply by the LCD, which is 2 times x plus h plus 1 times 2x plus 1. So now what we're going to do is clean up this numerator here. The denominators are gone. So this becomes 2x plus 1 minus 2x minus 2h minus 2 all over h times 2 times x plus h plus 1 times 2x plus 1. So what cancels out here? The 2x's cancel out. Oh, what happened here? Two times x plus 1 minus 2x minus 2h, oh, plus 1, sorry, plus 1, but it's a negative, so this would be a minus 1. Sorry about that. My son just came in and interrupted me for a second. Say hi, Danny.
Hello.
Okay. So now this plus 1 and this minus 1 cancel out, but you could have found that out because you could have seen my little algebra mistakes. And what we have left is negative 2h. That's the only term left in the numerator, and we have an h in the denominator, so those h's are going to cancel out. So f prime of x is equal to the limit, as h approaches 0, oh, we should have put that up in there, of negative 2 all over 2 times x plus h plus 1 times 2x plus 1. And when you substitute h equals 0, you're going to get 2x plus 1 times 2x plus 1. So it ends up being negative 2 over 2x plus 1 raised up to the second power. There's the derivative of that original function. Now let's find the derivative when x is equal to 3, f prime of 3. So substituting x equals 3, we get 2 over 2 times 3 is 6 plus 1 is 7 squared, negative 2. So this derivative is equal to negative 2 over 49. So there is the slope of that rational function at x equals 3. And I think I've done enough examples today. See you tomorrow.